Welcome everyone to our virtual meetup of the CNCF Cloud Native Heidelberg group. We indeed today have only one talk, one virtual talk for you from the colleagues here. I'll come to that later. Again, we had to do a little bit of rebranding and an update of our community because the Cloud Native community group gave some strict guidelines. So here is our new logo. Hope you like it. There's some links here you can later click on to find access to our community. We record everything in YouTube, and it'll be preserved and archived forever. Today's talk is about CRO, simple Kubernetes resource orchestration, and there's a lengthy abstract, but actually I rather like this abstract here. This is from Christina Andonov, I think a colleague, product manager from at AWS, and she actually, I hope it's readable here. I highlighted it. It says Kubernetes just got one step closer to becoming the front door to your cloud provider, whichever one you happen to use, and that I think is really the edge, the gate, the sliding override to, I think, Jesse or Amine. Welcome to our meetup. Please take over.
So yeah, we're going to talk a little bit about CRO, which is a new project that we started. We had initially started this at AWS and discovered that some colleagues in the open source community at other cloud providers were working in similar spaces. So we combined our efforts, put some of their ideas and our ideas into a single project. And now here we are with CRO, which is frankly gotten a lot of traction, a lot of interest. So we wanted to take the opportunity, got the invite, thank you again, to just explain what the project is about without kind of a lot of the marketing hype and the noise that's happening. So yeah, let's talk a little bit. Again, my name is Jesse Butler. I'm a product manager in the EKS service team at AWS. And Amine is my colleague. He is an engineer in the EKS service team as well. So I think we can all take just as truth that Kubernetes is a very common component in modern platform building. So we look to some of the concepts of Kubernetes and its design principles, and it just fits really well. And I think we can look back at those design principles not being accidental, but really sort of the declarative configuration, continuous reconciliation, the way that a Kubernetes cluster behaves is really like an implementation of how you want a DevOps platform to behave, right? And it's fully extensible. I think the initial authors, the initial creators of the project did a really good job of saying, we're not going to boil the ocean. We're not going to solve all the problems. We're going to give you really good, powerful abstractions and then make sure that the system is extensible. So we have this thing that we started calling the operator pattern, which is through custom resource definitions and controllers, which will extend the capabilities of your cluster, which really is kind of the fuel for the CNCF ecosystem. All of these additional functionalities, the additional projects that you can use with Kubernetes, most of them work through custom resources and dedicated controllers. So it makes Kubernetes really ideal. And I think I'm preaching to the choir here. It's not a sales pitch. This is just a statement of fact. Kubernetes is ideal for modern platform building. And what we see is a majority of Kubernetes enterprise adopters have established dedicated platform engineering teams. Sort of starting out, sure, you have an Amex and a computer. You can start anything, you can own or operate. But when you get to scale, it becomes almost mandatory that you abstract some of the difficulties away. And I think that's a really interesting thing to look at, is that Kubernetes is incredibly powerful and it doesn't try to solve all the world's problems for you, which means that for a developer trying to scale, there's a pretty steep learning curve. Very easy to get started. But once you get up into the 300, 400 level, you become DevOps, you become an owner-operator at scale, right? It's difficult to just think about your business logic and also really deeply, expertly use Kubernetes. Fundamental to our interest here is that there is a sort of a period of time and maturity that it takes to really understand the KRM and resource relationships within inside the cluster, and managing resources and applications together, where you stop thinking in terms of, oh, I've created a deployment and I have a service, but really using Kubernetes as a platform to build and ship software systems. And for developers, that becomes what Amine calls YAMLplexity, right? It is just an explosion of YAML. If we think back in previous years, it would have been maybe an explosion of XML, right? It's just massive amounts of configuration and specification, and who wants that? So we have platform engineering to abstract it away, and they have a very difficult job. It's very challenging. You're meant to standardize and simplify with minimal constraints, so you still have all the power of the system. You have to extend to meet the business requirements, but put everything on rails. Like, paved paths are your friend, but defining them is very difficult. Your job is to establish and maintain organizational standards while still keeping developer sort of autonomy secure. And you've got to tame all that resource complexity, because at the end of the day, a Kubernetes cluster lives and breathes on resources. That's its whole mission, is to create and manage resources. So we have the operator pattern. You can create custom controllers, and Kubernetes is endlessly customizable. You can do whatever you want with it. As we've seen, even ordering pizzas from Domino's in the United States, you could do that. You can literally write a controller for anything, throw a resource in the cluster, and it'll take care of it. But of course, this requires specialized knowledge. It requires an ongoing investment, not only to build the controllers, but also to maintain them and keep them sensible and healthy and whole. What we often see is that sort of the orchestration and the configuration of other resources becomes the reason you create a controller. So you literally, I've talked with large teams where they have a handful of controllers simply to leverage other controllers, right? I've got this thing from this project, that thing, this abstracts that API, and now I have a controller to manage them. And I think that we would all agree that a custom controller that doesn't implement differentiated business logic, right, it's not part of your application, is effectively technical debt. Now, you might willingly pay that technical debt because it solves big problems to abstract things for your developer teams in a platform engineering context, but at the end of the day, it's still technical debt. So we thought that Kubernetes could use a new feature. And that's where Crow came in. So with some of these problems in mind, the project really sets out to fulfill like that gap in the Kubernetes feature set. What we wanted to avoid is creating like kind of yet another CNCF project, which is an end-to-end sort of, you've got to learn this and adopt this and use it. We really wanted to kind of get down to first principles and try to solve a problem within the cluster. So Crow is a native and structured framework for resource group orchestration. So specifically that use case of like, I've written a controller to manage other controllers, right? We wanted to sort of help get out of that pattern. And in kind of sorting out how to solve that problem, we came up with some really interesting pieces of technology. So Crow will abstract and automate Kubernetes extensions and customizations. And we'll talk about that a little bit. But then there's been a lot of comparison to other projects like Crossplane or comparisons to Helm. And we certainly didn't set out for those comparisons. And we want to actually make sure that people are looking at Crow as more of a primitive. It's more of a technology and a capability for your cluster, where other projects could absolutely integrate with it and leverage it as such. So it was really important that we provide a simplified in-cluster experience versus go and download this other application and these other CLIs and all these other pieces to then solve these problems. What it does in the clusters, it enables a standardized deployment across environments for your cluster and then out to other clusters and in other providers, right? And particularly, we wanted to make sure that we were addressing the problem for all Kubernetes resources in any Kubernetes cluster. And that was one of the things that facilitated us to continue discussions and then eventually collaboration with our friends at Azure and Google Cloud, along with dozens of other contributors. So you see some stats. We've had a really slow and steady growth of interest, which we typically measure with GitHub stars. So we're almost at 1,500, which has been great because sometimes a project will go to like 6,000 and you just get overwhelmed. This has been a really nice, slow and steady kind of climb on interest. And we have a lot of contributors from a lot of companies, hobbyists, individuals, universities, college students. It's been really great. So if we look back to platform building, so how does Crow help? So it helps you with a few specific things. So it helps to author and distribute what we call building blocks, like cloud building blocks or platform building blocks. So this gives you kind of an easy path to building these high-level abstractions, which can contain other Kubernetes resources and their configuration. The configuration can be shared across resources, and then you specify through CRD authoring what amount of that configuration you expose to your end users, right? So the people that are consuming your custom resources and creating instances and clusters. So this gives you the ability to sort of inherently set your organizational standards and best practices and hardwire them into your custom resources. It also kind of unifies, it gives us a path to unifying cloud and Kubernetes resource management because we have several projects out there that can help you integrate your cloud resources into the cluster, like ACK or KCC or ASO or Crossplane or a number of other options, or maybe your own custom controllers. So it kind of unifies that and gives you a single resource to deal with. And also, like as I had said, it just simplifies CRD authoring in general. And we'll talk a little bit about that as well. So some of the core concepts here, so I'd said it's structured. So we took a structured approach to resource definition, specification, and management versus something that's like client-side templating. So we don't have a lot of bells and whistles that you might be used to from other solutions for this problem space. We're explicitly a non-Turing complete technology. We don't have functions. We don't have sort of advanced programming constructs. We don't have for loops embedded in the specification language. But we find that it is expressive enough for most scenarios. Most of the things that people want to do can be done with the pieces that we have put together, which is effectively the simple schema and cell. And we're really leaning into declarative reconciliation. So we don't do patch transform. We just have resources under the covers that are managed through like typical KRM. So the declarative reconciliation control loops. The resources that you create are verifiable. And we do static analysis of them. So we statically verify them before you deploy them into a cluster, which can help prevent deployment and runtime surprises. We can kind of validate things are correct for you. And it enables tooling to sort of take advantage of that. So you could imagine like a CLI that would be able to verify things before you deployed a change. Security and performance are obviously paramount. If you want to be part of a platform solution, you have to be transparent. So we have a sandbox runtime execution environment. We have explicit resource usage controls, and we have very predictable performance characteristics. Automatic dependency management is a big piece of using multiple resources. So one of the things we knew we wanted to solve for is if you want to create a custom resource that's composite of 4 or 5 other resources, what we don't want you to have to do is think about the ordering of operations or kind of priority queues or anything like that. So what we do is Crow will build a DAG as part of kind of analyzing and ingesting your specification and turning it into an RGD. And it will infer the resource ordering based on the configuration. So we'll order the operations for resources, creating them. And we'll see a little bit of that as we look at some demos. It'll become very obvious. as to how we do that. And we have kind of on the other side of that, we can do safe cascading deletions. So making sure that we don't rip the rug out from something. We kind of unwind things the way that we create them. And this is kind of one of the big aspects of the project, in my opinion, is, I've written a number of operators with a custom controller, and you specify your CRDs. The way that we enable CRD authoring is through that simple schema, which we'll look at in a minute. And we will dynamically create, based on that spec, we dynamically create and register the CRD in the cluster. And then the single controller, the CRO controller, will adapt in place to support that new kind, that new resource type. So you no longer have to think about the sort of more robust definitions of CRDs and having a dedicated controller. Through the RGD, which we'll look at, you specify that CRD, what you want that CRD to look like, and we'll create it for you on the fly, register it with the cluster, and then manage the resources for it. And yeah, we have a lot of kind of facilities for being able to detect breaking changes. And as you're moving versions, you can check for backward incompatibilities as you're working with the resources. And all of that is wrapped up in this simple schema, which is part of the project, which kind of de-YAMLizes a lot of things. So we remove a lot of lines of YAML and a lot of complexity in our configurations. So it's a human-friendly, like very readable schema format that compiles down to open API spec. So it's fully compliant solution. It's just easier to use. And it's much easier to reason about kind of changes or debugging issues that you have. So we look a little bit closer. The two main pieces of the RGD that I want to look at are the spec.schema. So this is the thing that effectively allows you to define the resulting CRD. This is the thing that users will consume in order to create instances of your custom resource. So you can see there's a kind, there's the specification, and it's very simple. The other thing here is that you can have a number of resource configurations under the covers that you just don't expose. And I think as a platform engineering building primitive, I think that's really powerful. You can say, oh, these are my object storage buckets. This is my NoSQL database instance. These are the configurations that organizationally we enforce. So you just don't expose them as configurable at all. They're just immutable. They're just baked in. You can also set sensible defaults for things. So here you can see we have an ingress, which has an enabled true or false flag, and the default is false. So if you don't put it in the spec, then you just don't get one, right? So it gives you a lot of expressibility, and it also allows you to hardwire in configuration, which is, I think, really important. The other piece of the RGD, so that was the CRD definition, this is the resource specification. So this is just as you would expect resource kind of specifications in a stack. You can have any number, they can be any Kubernetes resource that's available in the cluster, and you can inject configuration from other parts of the RGD. So here you see at the top one that's highlighted is from the schema itself, just popping the name out of the schema that the consumer created an instance and said this is the name. Another piece down below is out of the deployment, which is another resource. And this is some of how we do the ordering. We see here that you have specified that you want to take the match labels value off the selector in the deployment spec. So we know that the deployment needs to get managed before the service. And so this is how we'll do ordering. And you could do this in a lot of ways. I think one of my favorite is like a terminated load balancer. So in your cloud provider, you need a certificate and a load balancer. And you may have something where when you create the load balancer, you can then annotate it with, say, the resource name of that spec, of the cert. So we know that you'd need the cert before you need the load balancer. And CRO will just figure that out for you. And you just put it into the specification here. And so all of the resource ordering and the kind of thinking about the order of how you specify things becomes more of how you think about configuration and how these resources interact. So yeah, these are kind of the core features. I think we've poked at this enough, or we've looked at things enough. I think we should just kind of get into a demo. and see it in flight, and then we'll leave room for questions and stuff. So I can pass it over to Amine.
For today's demo, I have only one very simple example. I want to talk about. So before that, I'm using a current cluster. So if I do kubectl cluster info, you can see I'm using just a controller locally. There's nothing on any cloud provider, so you can use Crow with any Kubernetes, just the API server if you need to. And for this demo, I'm going to be using an alias. So K is for kubectl and a few other things that I'm going to show on the way. Anyways, the example I want to talk about today is like, hey, as a platform builder, as an owner of your cluster, you want sometimes to offer something like this to your users. All I want my users to do is to provide, give me something called S3 application. I want them to give me the name of the application, the image that I want to run, for example, here, Nginx, and whether they want an ingress, like whether to enable it or disable it. And what you want to do under the hood here is like, hey, I want this to magically go and create a deployment, a service, an ingress, and an S3 bucket. So there's like 4 resources. Typically, if you want to do this, there's like a few ways just to like tackle all of them. So you can either have your custom controller, you can use customize, you can use Helm charts. But things get very tricky when, for example, you want to get the S3 bucket on and inject it into the environment variables of the deployment. Like those are the things that where you need a custom controller. Or at least like with Helm, if you want to do it with Helm charts, you need to use post-deploy hooks or pre-delete hooks. There's like multiple, what Jesse likes to call duct tape. There are like multiple hacks to make this work. But for today, so what I want to do is like, I want to go and install this. So I'm going to go and create, actually, I'm going to do an apply. And I'm going to do, hey, can you go and do this for me? And what I'm expecting under the hood, it's either my controller is too fast or too slow. Okay, actually, let me do. Oh, I did. Sorry, didn't install the RGD, so I'm gonna have to delete this. Like live demos always. So I'm gonna do. So there is this RGD that Jesse was talking before. So I need actually to configure the controller to be like, hey, go and manage my instance for me. So and this RGD is gonna have all the specifications on how to handle the instance. I don't want to show it yet, but this is like now Crow is ready to go and manage my instances. So if I go and do an apply-f instance, okay, now things I see that they are working. I have, by the way, some logs on the side. This is why it feels a little bit magical. But so if I do, for example, hey, give me the buckets, you should see something like, oh, I have like my S3 Heidelberg, my awesome app S3 bucket that just got created 13 seconds ago. And if I look at the deployment, deployment service ingress, I can see like that just a few seconds ago, we had like this deployment service and ingress that just got created. And if I go and investigate my deployment, so if I check in here, you can see that I have some environment variables injected into the deployment saying, here is the S3 bucket. So there was a lot of things that Crow did under the hood, and I'm walking just backwards to show you how to configure Crow to do this exact same thing. So let's walk a little bit back and let's check the application that's the RGD. So also as well, for maybe for the sake of the demo, I'm using an alias called bats. So if you see like a lot of weird like cat behavior, it's called bats, which is cat with wings. So when I do a cat application RGD, you can see this. So for this application in here, what we're doing is that we're telling Crow like, hey, can you go and create a CRD for me that is called an SV application? And here is the fields that the user will have to provide. And here is the status fields I want you to pass back into the instance, which we will go and see in a bit. So something very interesting about status fields is that you don't want them to be just data. You want them to be really expressed with something that you understand. And in this situation, we're using cell expressions to be like, hey, I want you to inject the deployment conditions back to the instance. And I want you to tell me how many available replicas are there from the deployments. And you can also add more things like, hey, like I want the S3 bucket status, and I want to, for example, see my custom CRD, some specific status field or even spec field. You can inject them in there. Anyways, so the other part is that we needed 4 resources. So deployment, service, ingress, and S3 bucket. This is following the same mechanics. So in here, we define our resources. There is, the first one is a deployment. And you can see that we're using here the word template. I like to describe this as more like C. It's closer to C++ templates than to Helm templates or Jinja templates. It's not really very dynamic templates. They are very structured. You can only use like resources, for example, you have in the cluster. So what Crow does under the hood in here is going to go and really validate whether this resource makes sense, whether those cell expressions make sense. For example, in here, I want to inject the user specified spec.name, which is defined in line 13 in here. So go pick up the name, inject it in my deployment name. And you can do the same thing for the image, and we can see here the container name is taking the same name above. And I will get to those in a bit. So those are like how you define the environment variables, and you can like point to different things. But before getting into there, you can see that the service has something a little bit special in here. It's not using a spec, only a spec name, but it's also using a deployment spec selector match labels. It's telling Crow like, hey, go to the deployment, which is this resource defined in line 24. Go and pick my deployment match labels and inject them as a selector to the service. And this way, you're telling Crow like, hey, you're making sure that you will never mess up like your match labels and selectors between the deployments and the service. So this is the first link we're doing in here. The second one is we're using something very similar with the ingress. So we're creating an ingress, but you can see here in the service name, we're not using a user-provided spec. We're using the service metadata name. And this instructs Crow to go and pick the service metadata name from line 51. So this is the second link in here. I need to get the metadata name from the service, inject it into the ingress. And something like a little bit simple in here is like conditionals that we have in Crow is the include when directive, which tells Crow basically, hey, only include this resource if the user sets enable to true. Now to the custom part. So now we've been seeing only native resources in Kubernetes. The same way you've been defining deployment, service, and ingress, you can just like say, hey, here's my custom CRD. I want to create an S3 bucket. Here is the name of the bucket. And you can see here we're mixing cell with literal strings. So you can see here I'm prefixing it with S3 Heidelberg, and I'm doing a schema.spec.name, which is provided by the user. So let's go back to the deployment. The deployment did something a little bit different from the other resources, because the deployment was actually referencing the status of the S3 bucket. So here we're saying like, hey, I want to get the status ACK resource metadata .on, which gets the S3 bucket on and injected as an environment variable called on. On top of that, we're also adding another variable called, we're doing the same thing for on, but this time we're calling cell functions. And this is where Jesse was talking about like, hey, it's not Turing complete, but you can do a lot of cool things. You can have actually most of the functionality, like, hey, if you want to transform strings, if you want to split them, if you want to like take just parts of them, you can see here we're trimming the prefix that AWS injects that has like the AWS and the account name and things like that. We're just removing it from the string so you can get only the bucket name if you want. There are multiple ways of getting the bucket name. For example, you can get it directly from the spec. But just for the sake of the demo, we're just like showing how you can get it from the status. Anyways, this is like the general way of how we defined our application. Now, if I look at the RGD under the hood, so if I ask Crow like, hey, what's my RGD? You can see here that it says that it has a state active, meaning that Crow did some static analysis, made sure that it's actually working, and it makes sense, and then started serving the new CRD. If you do a -OY, you can see what we call a topological order in Crow. And you can see that here Crow detects that it needs to create an S3 bucket, a deployment, service, then the ingress at the end. And if you go and do, let's say YAML, let's actually do YQ here. There is something very interesting into this file. If you remember in the beginning, maybe I'll use a cat better. Let me do this. So in the beginning, we started by defining the deployment first, the service, the ingress, then the S3 bucket. But that didn't matter for Crow. It still like swapped resources and changed the order on the fly. So if I go and do this again, you can see in the topological order, Crow detects that S3 bucket should be created before deployment. So by just like linking and referencing resources, you're defining a dependency graph, and you don't have to explicitly mention those dependencies. You only like let Crow like understands what's happening. And when we first deployed the which a CRD called S3 application, we can see here that it says distinct, active, and if I do a -o YAML, now we can see those status fields that we asked Crow to inject. Let me actually use a YQ again. So do you remember the available replicas and the conditions we want to inject from the deployments? Like Crow literally just executed the cell expressions, took the available replicas from the deployment like status fields and the deployment conditions and injected them in here. And those conditions are not Crow conditions, actually. They are the conditions applied by the Kubernetes deployment controller in the controller manager. So yeah, this is it. Like if I go and do a, for example, if I come in here and say, I want another awesome app, actually, let's do this. Awesome app number 2. So if I want to create a new one, actually, maybe I need, okay, let's do CNCF Heidelberg. And if I go and create this, so it's the same almost instance, but with a new name, it should just create a new S3 bucket for me. So if I do get S3 applications, I should see that one was already active. The second one is in progress. It has a new different name. And if I check the buckets, there's an S3 bucket with the number 2. And if I do deploy SBC ingress, I should see more than just one. Because yeah, so one 10 minutes ago and one in the last few seconds. And yeah, I think that's it overall. This is. I just like gives you a glance of what Crow could do. You can definitely use it with any CRDs. You don't have to use it with any like specific only resources. It can be used with ACK, crossplane. I don't know. I know in SAP you have a lot of controls as well. Vazu, Gardner has a lot of operators, so definitely there's something you can use with Gardner under the hood. And yeah, with that one, I'm gonna stop sharing my screen and I'll give it back to you folks.
Thank you very much, Jesse and Amine. I'll open it for question. I think we have a couple of questions in the Q&A. Maybe Jakob voted up. You have a remark, maybe?
I had a couple more slides, but I will come back to it.
Okay.
Yeah, so the comment is, I love the resource dependency inference based on cell expressions. I think it would be super cool to externalize and offer the cell parser and DAG of Crow into a library so it can be used to solve arbitrary dependency graph problems. In my opinion, this is huge. Maybe that's something that could be drawn out into a library to open up and reuse, or to open up reuse. Yeah, I mean, do you have, we talked somewhat about some of the components of Crow as a discrete implementation being reusable. Simple schema was one of them. Like, do you have any thoughts on this?
Yes, that's a very good question. I believe that it's really like good components that we can reuse for other applications that other operators, other people want to use them internally. And actually, like currently, you can do that. So we have a cell library to do what we call cell inspection. So it can pass into the AST and do a comprehension of the cell expressions to understand who depend on who. I'm gonna start sending links while I'm talking about this into the chat. So this is the first one. The second one is you can use the DAG library. So we have a DAG library that you can use to build your own DAGs based on what the output of the cell library is doing. And regarding parsing and getting the cell expressions from resources, you can use what we call a parser. So we have like this very generic parser that you can use with any Kubernetes resource that could help you do that. And yeah, like honestly, we put everything under PKG because we want them to be importable. There is no way for us to make it internal. I think it's pretty reusable. And if other folks want to make them more generic, and there's like something that could help you, or like some functionality you think it's private and you want to make it public, please like send us PRs. We're very, very open to make things importable and reusable. And even if you don't want to import code directly, we're open to make specific libraries on the side. Like I can see once in the future for sure, we might pull things like simple schema. It can live in its own little home without really living inside Chrome.
Yeah.
Jakob,
Cool.
you want to unmute yourself? And
Yeah, I didn't know how fast you were gonna go through the questions. So yeah, first of all, I appreciate it. Of course, sounds good. I went through it already and I implemented some, I guess, small dependency library based on the cell parser that you wrote. So this is good stuff already. Have to make a big shout out here. I think in general, I'm mostly interested if we can even separate it into a separate Go module, but I can open up an issue for that, right? That's not the place to discuss that here. And in general, I think you will see maybe a PR also where I introduce comp ordered generics on it, so I can use it for other things than string graphs and stuff like that. But generally, again, really cool stuff. Happy to see that you're open for contributions.
Very cool.
I think Jayesh, yes, indeed. Shout out to you. Jayesh, you had a question. You want to unmute yourself? And just ask it live.
If maybe he stepped away. I could do the reading thing again.
I think he has problems unmuting or... Okay, maybe. Oh, he can't unmute. Let me try.
Oh.
Funny. It's all a new infrastructure. Let's see. Oh, I can't. No, there's a blocked by permission issue. Okay, I can't. Oh, I think you logged in, Jayesh, without the permission when it asked the browser.
Yeah.
All right.
Likely it's a browser setting on the upper left next to the URL. I think you can explain to most browsers that you want to give them access to certain assets of the
I can read it out to you, Jesse. So we have this interactive behavior.
Sure.
So we're already, so this Jayesh question, we already have deployment using GitOps with FluxCD. How can I make use of or fit Crow into FluxCD-based GitOps solution?
Yeah, that's a great question. I think one of the things that we like about this approach is that it's super like it just drops right into GitOps. There's no additional controllers required. You don't have an external system. There's no other specification. So Crow is just a CR, right? And the custom resources you define with it are just CR. So they're just Kubernetes manifests. So they should just work very, very abstractly with Argo or Flux or Bash scripts and duct tape, whatever you're doing GitOps with. But yeah, I think, what's implied here is that there is a deployment in FluxCD. If it's just a deployment and that works for you, there's not necessarily a reason to grab Crow unless you want to make that deployment a little bit more of a paved path for other parties, right? Because that's the thing we didn't even really talk about. Like you could just have one resource in a Crow custom resource that exists only to hardwired kind of configuration, right? we only run on port 80. Okay, you just put that in there and now you have your special deployment. But I mean, if it's just a deployment, you're happy with it, you don't have any problem to solve, there isn't necessarily reason to use Crow, which is kind of another reason we love this project, is it's very specific for, I mean, it's very broad. You can do a lot with it, but it's pretty specific to, do you have a problem around custom resources, composite resources, and managing resources at scale? If a single deployment works, that's fine. We love Flux. But I think that's the answer, right? If you have Crow resources, should just work very, very kind of seamlessly with GitOps workflows.
I think you can also deploy Crow with Flux as well beforehand.
For
right?
sure.
I mean,
you can.
It's a staging thing, I would think. I think it's my question next, but can I have 3?
Sure.
Okay. So one thing I think I already know the answer through Amine, but I think you also take care of the reconciling. So in your example case, if for any chance AWS had to change the AWS bucket status that has been fed back, some name change or something like that, you automatically run a reconcilement of the deployed resources, right?
Think that's good. Yeah, I mean, I'm going to look to you for that.
So, yeah, Crow is a controller. There's a reconciliation loop under the hood. So every time it's gonna, periodically it's gonna come back and be like, what's the desired state in here? I'm seeing something in the RGD is very different in the cluster. I'm gonna go and fix things. So if someone go and change, for example, the S3 bucket, say the tags, for example, and you have different tags in Crow, they're gonna get reconciled. So there's this different mechanism that Crow believes that it's the state of truth. The RGD is the state of truth. So it's gonna go and reconcile that under the hood. Yeah, we have some plans into making instant reconciliation. So if someone goes and modifies something on the spot, like let's say you go on and change the deployment replicas to 5 and it's supposed to be 3, we could also react on those changes. We don't have that today, it's come periodically, but it's something we can support in Crow for sure. We have some conversation happening on GitHub.
Okay, and so my second question, I put that in the Q&A. So the state of many, I mean, Crossplane has states kind of standardized, I would say, with conditions, but I see there are lots of different ways of how controllers report back state, right? And have you found that, I probably can use Cell to do the mangling of the state if I have to look through a couple of variables or attributes and then or substring that. Is that sufficient to figure out, okay, this is when something is ready, or is there something where I would need something else that Cell doesn't provide? Just wondering if you've come across such scenarios.
Yes, so we've seen people actually already solving this problem with Cell. So let's say you want to wait for a resource to reach a specific state, and your state is very complex. You want to use and or operators. You want to use macros like filter, exist. If you have an array and a map and you want to look inside those elements, actually Cell has a very rich mechanisms on that lets you go and inspect something deep. For example, you can say, hey Cell, can you go through this list of conditions and find the condition that is called think, and I want you to assume that it's true, and I want you to also to look at the replicas, the available replicas to be 5 and the spec replicas to be 5 too. So you can really be creative in how you want to tell Crow what is the state you're looking for.
Which means you're kind of Turing complete in structural fixed environment and in structurally fixed areas. Yeah.
Yep.
Okay. All right. So, and that's great. Yeah.
So for example, I mean, one of the things you cannot do in Crow is a lot of nested loops. Like you cannot have a for loop of a for loop of a for loop with unpredictable, like with functions that you don't know what's happening inside. As long as we know what's happening, for example, if you're doing a filter or executing a macro overall on an array, and we know the size of the array, we can predict the cost of the execution. And like this is the whole idea of doing cell, or why cell exists in the API server in the beginning, is every expression is has a predictable cost. And we have a runtime budget, so we can tell the Crow controller, hey, I don't want you to execute more than, I don't know, X amount of CPU cycles, or execute more than 100 cell expressions a second or something like that. So we can literally like tweak it and start doing some throttling at the runtime level.
Okay. And my third question is the following. So I think you define with your simple API in the resource group, you basically create a CRD, right? And you mentioned that you can protect against backwards incompatibility and breaking changes and so on. Now, if I go in and structurally change this API, how do you do that? I have already one or application RGD running, and then I'd like to change it, right? And even there, CRDs are not complete in the case that you have to move attributes in such a way with in step by steps, move it into fields, annotation. There are many ways how you get around. How do you get around that? How do you get compatibility in that? Do you have some samples that?
So yeah, for sure, I can share my screen and show you what's possible and what's not. But in general, like Crow is not against evolution. If you want to change your RGD and change your CRD, it's possible. What's not possible is to introduce breaking changes specifically. For example, making a field or adding a new field that is required. So if you already have instances that don't have the required field, it's a breaking change if you make it required in the CRD. And if you want to add something required, usually the solution is to give it a default, so that the API server doesn't, it's gonna default it on the fly when you need the resource. So Crow doesn't really block you from evolving. It just warns you if you're making something that's gonna break your CRDs.
Okay, I get it. Yeah, that's neat. Yeah, and because you'd have that control over there, but. Okay. And because your Crow that accepts that RGD is a control itself, you can just block any such breaking changes. Okay, got it.
Yeah, that's exactly the idea. Like you have your desired state in the RGD and the actual state in the CRD. So we can calculate the diff. Actually, we can see what really changed. And we can see that new fields, the existing ones, the defaults that got added, if you change patterns, if you change description. For example, changing description is fine. If you do that, we observe it, but we don't really do anything about it. That's the main idea under the hood.
Thank you. I'll open up. Anybody else has a question, please unmute yourself if you can and use the opportunity.
We have a question in chat that's not in Q&A from Rafael.
Okay. Rafael, do you want to unmute yourself if you can? If not, I will read it out. Is it okay? Maybe not strictly Crow related. What is the idea to go forward with other APIs, GitLab, Artifactory, Argo CD, etc.? How can I consume those with Crow? Should I use the crossplane providers?
I'm not sure I fully understand the question. Crow, you can consume any API in the cluster. So you can create an RGD that includes resources of any kind that are available in the given cluster where you're creating the RGD. That could include cross-plane resources. It could include custom resources. If there's like a GitLab controller, Argo CD, obviously we already talked about, right? You could actually have a Crow resource that is an application set, which also has something like, I don't know, a log resource and maybe, just basically arbitrary resources that can be pulled together. If the question is specifically about like the GitLab control, like the GitLab resource in Crossplane in this example, then yeah, if you wanted to use that, you would use that. I think what's interesting is that there's a good integration there. And we've talked to the Crossplane maintainers. They're interested in potentially finding a Crow integration. So this definitely is not trying to replace Crossplane, but what it is I think is providing a new way to think about something like an XRD, whereas Crossplane's got a lot of value in other spots as well. We could integrate Crow with that, right? So I think that's sort of the answer, which maybe not a very specific answer, but that's because there isn't one. I think whatever your use case is, I think you can consume Crow, you can leverage Crow to solve the sorts of problems that it solves.
Hey, thank you. I just needed to get my plugs. I was not ready to be visible. Hey, yeah, that was my kind of answer, because Crossplane is providing the whole ecosystem. You have a lot of providers that talk to different APIs, for instance, GitLab, and Crow is only like the glue in between. And
Correct.
That will be my answer if I want to start with my question. If I want to start with Crow, which providers I should use? And right now, Crossplane is only providing this big ecosystem of providers.
Correct. Yeah. I mean, I think it's two different problems, right? So the idea of having a GitLab controller or a PagerDuty controller or something like that, those are, or even, controllers for Google and AWS, right? There's a lot of providers in Crossplane. So that gives you the sort of CRD model for various external APIs. Crow isn't trying to do that. Crow is specifically just about, and just to be clear, this is not a first step in this wave to take over the world, right? We are really about the Unix philosophy at the Crow project, and we are not about scope creep and boiling the ocean. So we intend to basically sit right where we are. We think we have a really interesting and novel solution to the problem of resource and controller explosion, and we can help minimize that. So yeah, you can use Crow with Crossplane. We have a lot of customers at AWS that use Crow with ACK. Google may have customers use with KCC. Azure has ASO. Like, there's a lot of options that you might choose, and anybody can use Crossplane with it as well. So yeah, thanks for asking that, because it is getting compared a lot, and it's great to have other people aware that that's not the mission. We're not trying to replace anything else. It's specifically about resource orchestration.
Yeah, but there is a comparison to compositions from, so
that's XRDs,
kind of
exactly.
the same. Yeah.
Right, and there's a number of other things too, right? I think Kubevela has something. I think I just saw actually a brand new project like from a couple weeks ago, which, forgive me, I can't remember the name of. There's a lot. I mean, I think it's a pretty hot area, which is another reason we were really interested in sharing our idea. Like, ideally, we'd love to see this land maybe in a SIG someday or something, and just be part of a cluster so that everybody can use it.
Anybody else with a question? Please unmute yourself or paste it in the chat.
Well, if I can show you a couple more quick slides.
Oh yeah. Because
nothing heavy duty, but I did want to share. Did I do it? I did it. Yeah, I just did want to say what's coming next for the project. We're kind of marching toward code complete. We have a couple of milestones. .3, we're trying to put one big feature into each milestone where we get a kind of community input, and a lot of people talk about it on Slack and in the issues, and then we bring it to a milestone. So the two remaining features that we think we need for code complete are external references, which is being able to refer to something external to the RGD in its spec, so like a config map or secret. And then also collections. So as Amine and I both said, we don't have looping. But we do think that we have a really good plan for collections or groups of resources, so that you can't have arbitrarily nested for loops because we have a DAG in play, but you can say, I want 8 of these things, right? So that's sort of what we think. And so where we find most use cases are satisfied without for loops, we think now like 99% of use cases will be solved with collections. So those are the 2 big ticket items left on our way to code complete for alpha. And in the project, so we have the project that obviously is super open, is fully provider agnostic, it is cloud agnostic, it is ideally everyone agnostic. And everybody is welcome to join and participate. We have adopted some light CNCF governance. So we don't have full like talks and oversight and all that stuff because we don't need it yet, but we have basically all of the things that would make the project familiar to you. We've adopted those governance mechanisms. And yeah, we have a Slack channel in the Kate Slack. So it's just Crow. If you want to join us, that'd be a great place to talk. And we also have a community meeting every other Wednesday. Tomorrow is the Wednesday. It is right now, I think 9 a.m. Pacific, noon Eastern time in the US. We're thinking about maybe doing a Europe-friendly time. So a little earlier, like maybe 9 a.m. for me, I would run one. And the Pacific people can just sleep. So we'll see how that goes. But right now it's bi-weekly at 9 a.m. Pacific. And with that, that's the end. So thank you again for having us. Really appreciate the time. And yeah, that's me.
Indeed. Thank you, Jesse. And my last kind of question was, you are adopting CNCF standards because the intention, I read it somewhere, is actually to also go to the CNCF at some point. Is that correct?
I think we'd ideally, yeah. So we'd ideally like to land in a SIG. I mean, we're really far out from that, but I think we would like to, I mean, it's already vendor neutral. I think we would like to donate it to the project more formally. And we're using the CNCF model because it's a very good governance model and it's what everybody expects in the Kubernetes ecosystem. So yeah, we wanted to make it really clear about like how the project works, how you can participate, what the code of conduct is, all of that. Those are really important aspects as we're growing. But yeah, we think more, I mean, whereas, you know, it's all Linux Foundation and then there's a CNCF and there's Kubernetes inside the CNCF. So it's technically CNCF, right? But I think we're targeting ideally a SIG. We don't know where that might be, but because we don't necessarily want to try to build a whole application set around this. We just want to, we really want to keep framing it as maybe a missing Kubernetes feature.
Super. I see in the chat a lot of people are thanking you for this presentation. Thank you for coming to our CNCF virtual in Heidelberg. And I see also there are a couple of people wanting to try Crow. So mission accomplished.
Awesome. Great.
Awesome.
Well, we'll see you in the project.
Exactly.
Thank you.
Thank you, Amine and Jesse again. Talk to you soon at the KubeCon.
Thank you. Yeah, we'll be there.
Bye-bye.
Thank you.
Thank you, everyone.